to all of you. Thank you for joining today's webinar session. My name is Mishti Hindlekar, representing Tekla India marketing team. We take this opportunity to connect all of you today for a webinar on bridging a gap, Tekla structures in bridges. Please do remember to send your feedback after the webinar. In this GoToMeeting tool, you have a comment box wherein you can type in your questions, and at the end of the webinar, we will try to answer your questions. This session will be recorded for your future reference and will be available in Tekla website. This webinar will be presented by Chandrasekhar, Engineering Manager, Tekla India. Hope all of you enjoy this technical session. I now hand over to Chandrasekhar. Thanks.
Thank you very much, Misty. I'll start the session now. The agenda in this session is on Tekla structures for reinforced concrete industry, where we will be discussing on benefits of Tekla structures in bridge structures and the downstream communication with their benefits, and the model interoperability features with third-party tools, and even the reinforced concrete deliverables part also. To start with, the benefits of Tekla structures approach. Always the model is going to be at the center with all the information, starting from the foundation, pier, all the segments, the normal reinforcement, and the post-functioning information also. When you start with the project, if you have any basic information, that we can directly bring into the Tekla structures environment, and we can see the detailing model as well as the analytical model in Tekla structures environment, and the same can be transferred to the analysis application to do the analysis and design. So once after that, we can bring it back and update the same information in Tekla structures environment, and then we can generate the general element drawings, and it support the multi-material. That means the steel and the concrete, and the user-defined material and user-defined sections. So once after that, we can generate the reports and the drawings and reports, the bar bending schedules, and even the fabrication integration. I have a rebar with the shape code and the bar size details that can be transferred to the machine, where machine will cut the rebar and bend the rebar according to the shape code assigned. And even we can do the erection scheduling, so that which one will go first, which one will go second, that we can plan, and even the construction management part also. So this is the building information modeling workflow in Tekla structures. And when we see the BIM-based workflow, now the construction industry is rapidly moving from 2D to the BIM-based workflow. So this provides, the huge potential to develop the productivity, less design, detailing and information management errors, and robust change management, the proper design coordination we can do, and extensive collaboration potential through the value chain and value network features will be there in the model. So definitely the less wastage and better quality and more productivity through reliable, accurate online data. With this model-based the design, the rich data-based information content will be there, and the 3D design and visualization is more easier. So definitely the less mistakes, more powerful change management features will be there in the in this workflow, and automated data flow is there, so no mistakes in the data transfer. So definitely the benefits are like the design coordinations, and then less number of the RFIs. And with the 4D, we can include the bill of materials, so that we can do the estimation, and the 5D contains the scheduling and planning information also. In the BIM pyramid, if you see this, the physical model authors, definitely when you take any project, it's a mix of structural, mechanical, architectural and electrical, so people are involved. So here, whatever the model we created in Tekla structures environment, the same can be transferred to the people who are checking this model. Even if they are not using Tekla structures, still we can share this model through Tekla BIM site, where they can view the model, they can review the model, they can give their comments and give their approval. We can check the status and we can see the feedback also. So basically, the communication is always going to be in 3D. So this is a new level of communication. So the present method may be writing a lengthy email and attaching a heavy PDF files, but in this the workflow, so we are discussing directly with the 3D model. So definitely the number of RFIs will be less in this case. In Tekla structures, the reinforced concrete, the information how we are managing is the model is going to be at the center. with all the information, and we can see the 3D rebar, and the drawings are generated from the model, and then the bar bending schedules, reports, the schedule and the clashes. So if we change any information in the model, it automatically updates instantly in all the areas, like in rebars, in drawing, in bar bending schedule, even in reports, and even with the clashes with the third-party reference model, it automatically updates. But whereas in the 2D based workflow, we need to ask each and everyone to come with the revisions. But whereas over here, in this workflow, it updates instantly. If you see the traditional workflow where 6 updates are required, but here in Tekla structure, it's a one single model and one single update. And the most of our the customers, what they say is Tekla structures is a in the area of reinforced concrete is a cost-effective solution, and it has model interoperability features with the third-party applications, so that we can transfer the model to any third-party application. At the same time, we can bring it back. And from the model, we can generate the cast units, and reinforcement, we can do the numbering, so that for each and every rebar, we can give the proper the bar mark number, and we can generate the drawings, reports, and the bar bending schedules. And it supports almost nearly 33 country environments. I mean, the 33 country standards of practice, like Indian, American, British, Euro, and by default, with the installation, you are going to get 33 country environments. And even we can export the rebar bending information to the machines through various file formats, so that we can automate the whole process. And Tekla structure, the reinforced concrete module can be used in different areas. So starting from high-rise commercial structures, and hydro structures, and even the bridge structures and industrial structures. But today we are going to discuss more on the bridges side. The workflow to build the model in Tekla structures for the any type of structure, but today we are discussing on the bridge side. We can import the CAD as a reference file. If you have any CAD reference files, that we can bring it into Tekla structures environment, like the DWG format or DXF format, that we can directly bring it to the Tekla structures environment to start with the project. Or if you have any PDF files, we can insert the PDF files also into the Tekla structures environment, so that I have some reference with me. When I bring in as a 1:1, I have some reference. Based on that, I can start building the model. And even if we have more number of PDF, the number of pages, even we can select the page which we want to insert in Tekla structures environment. That is possible. When we start with the project, definitely the first part we are going to do is on the foundation side. That is substructure, where we have different the options available. So these we call as a custom components. With just 1 or 2 clicks, we will be able to model the concrete part as well as the reinforcement for this foundation. Say for example, starting from the 2 pile cap or 3 pile cap or up to 12 pile cap, or the straight or the splayed one, even with the mat foundation with the piles. So the different arrangements are readily available, so that very quickly we can model the foundation for the bridge structure. And then for the superstructure side, some of the options are available, where the user can very quickly model the superstructure. So different types of the pier options are available, where one can see the options like the semicircular one, the square one, and even with the tapered, and even with some openings, or the user defined the shape and size also can be modeled very quickly over here. And then coming to the deck type, so different type of deck type we can model here, the simple to the T-beam deck slab bridges, even including with its parapets. And to maintain the proper slope, we have the options over here to give the depths at different levels, and even with the curved part, that is also possible. And even with the eye sections, you can see over here the one complete the eye section, and then the one of the tendon modeled over here with the end blocks. So I just modeled here only one single tendon, so that we can see clearly the details in the model. And then the segment side. So we can model the segments if it is a straight stretch or even in the curved portion, that we can model very quickly the user defined shape of the segments, and even we can repeat the same. And when creating the profile, different options are available, like you can by using the sketch editor or by using the polygon. So we can bring in as a DWG file also here as a sections. So those are going to be the fixed profile, and the rest are the parametric profiles, so that anytime you can change the concrete sizes. So automatically the reinforcement attached to that, it follows the concrete boundary. So creating any user-defined shapes, because in bridges definitely the shapes are the user-defined. So we can create here the user-defined shape, and we can make it parametric, so that later we can change the section details. Later also it updates in the model, and we can save this as a the profile in the database. So next time no need to create a user-defined shape. So it is already there. Just we can start using that profile. And then even in the curved the alignments, where we can model the decks very quickly, but for that we need to have the coordinate details. So for that we can refer to the information what we received in the beginning, or by just keying in the XYZ details in the Excel sheet, we can bring in the information for the decks in the curved portion also possible. Depending on the span length requirement, one can go with the simply supported RCC slabs, or the T-beam deck slab bridges, and the PSC girder bridges, and RCC weighted slab, or the continuous RCC weighted slab, and even the RCC box sections or the PSC box sections, and the simple to up to the suspension bridges that we can model in Tekla structures environment. And going to the next. So the model has all the information in it, starting from the substructure to the superstructure, and even the information like the expansion joints or the bearings with the abutments and the wing wall, or the what we call as the return walls, and the toe walls or the dirt walls, and handrails and crash barrier with the approach slab, and even the embankment details, so that we can add some more details like the median or the chainage information in it. So we can model here the starting from the culverts, viaducts, flyovers. It can be the segmental bridges or the cast in situ or the precast. So even we can add the drainage information also in it. So when we start with the live demonstration, we are going to take those areas also. And then on the deliverable side, what we are going to deliver from the Tekla structure model is, the first is the 3D model. Because it is an intelligent model, it has all the information in it, like the grade of the concrete, size of the rebar, and the shape code, and the chainage details. It has all the information in it. So we can send the whole 3D model to the third party, like the site people, so that they can open the model in Tekla BIM site, which is a free tool from Tekla. They can open the model, they can check, and they can comment, and they can reply back to us also can. And when we modeling the reinforcement with just few clicks, where the Tekla has the component library, by using that we can model the reinforcement for the regular sections, where for the user-defined shapes, one can model the shape of the rebar, and selecting the range, the reinforcement is there already. It follows the concrete boundary. And then it's not about slides anymore, because these are all parametric the reinforcement. I'm just showing you one example, where when the reinforcement sizes change, the concrete section changes, the reinforcement also adjusts according to the new concrete dimension. So they are parametric. So which is one of the very good feature in Tekla. And then on the deliverable side, the quantity takeoff. So do we have different types of reports, like the HTML format, ASCII format, HTML format we can generate, and we can get each volume for the volume of concrete pour, so that we can plan our pour sequence, the rebar bill of materials with all the bar mark number labeled, the size of the rebar, length of the rebar, and even the shape of the rebar, so that we can identify the rebar with the bar mark number, or with the shape code, or with the type of the rebar that is there already. And then even we can segregate the rebar depending on the size of the rebar, or with the shape code. That is also possible. And then the bending schedules generated from the Tekla, where we can select for any reports, we can select the member, or for the selected portion, or for the whole structure in one single go, or even with the faces also possible to generate the reports. And then coming to the drawings, where we can generate all the general element drawing, and then the elevations, the suction views. Here one of the example, what I'm trying to show here is the I section with the tendons modeled in it with the end blocks and the normal reinforcement. These are all linked with the model. Whenever there is a change in the model, the reinforcement also updates. And then the 3D model information we are sharing with the site people, and it has the lot more information in it. And by using the Tekla BIM site, as I said earlier, by using the Tekla BIM site, they can open the model, they can review the model, and they can send it back to us with their comments. That is possible. That means the communication is more faster and easier by using this Tekla BIM site free tool. And along with the good for construction drawing, so we can send them the 3D model so that they can see the whole model, they can walk through, fly through, check everything in detail before they go to the form works. That is possible now. The same, the information what we have in the 3D Tekla structures environment, we can send to the site, the total session machine also possible. By using the LM80 total session machine, we can transfer the points from Tekla structures environment to the total session machine, where the total session machine will transfer these points on the ground. Otherwise, the present practice is where we are sending the 2D drawing to the site, where surveyor need to recalculate the, on the reduced level and he need to locate. But here, all the points will be transferred directly from the total session, and at the same time, the site information can be transferred back to the design office also possible. So this is one more automation and to speed up the whole process. And then now we are going to do the live demonstration. What and all did we discuss so far? We are going to show some of the portion in our live demonstration. Now to start with the live demonstration, I'll be showing the complete model first, and then we can go in detail. So here I have the complete bridge model with all the surface information, what I received from the basically the topographical information, what we received from the highway team. And similarly, we can insert, as discussed in the slides, the reference model information we can bring in, and we can make it visible or invisible in the model, so that by using that as a reference, we can start building our the bridge model. So here I have all the alignment details and the reduced levels from the survey department. So by using that, we can start building the model. And here also we can use the clip planes, and let me just use the clip planes. So if I use the clip planes here, we can cut the section and we can see the information. Like you can see the three-dimensional, the tendon profiling, we can see in this portion. And then the normal reinforcement and the end block details, and even the crash barrier of the railings and the parapet and the abutment part, and even the piling information. So basically the model has all the information in it. And then once we turn on turn off the reference model information, we can come to the bridge structure over here. So here it is, all are the intelligent objects. So the one what I selected now is the pier, and the diameter is 1000 millimeters, and the grade of the material is the 40. So what we can select from the list. And when we see the reinforcement information in it, so if I check the stirrup part, it says the name is stirrup and the diameter is 10 millimeter and the grade is FE415. And even when I check the main rebars, they're all 25 millimeter in size. And even we can see the post tension tendons in the model. So we will be discussing one by one in the next the demonstration. Now to demonstrate the complete workflow, we will be starting with the culvert, where we model the culvert wall. The culvert wall where the thickness is 230 millimeters and the height is 3000, and the grade of the material is M30 grade. And here we have the options to select the grade of the concrete, and user can even include add the new grade of the concrete also possible. And even we model the top slab and the culvert bottom slab. And then to model the reinforcement, we have different methods. and even we have some reinforcement modeled over here. So first I'm going to show it with the custom component dialog box, where we are going to select the reinforcement and apply at on the slab. Now we can see the reinforcement. In one single go we can model for the whole structure for the slab portion, and we can edit in this dialog box, where we can edit the top cover and the bottom cover, and the size of the rebar, grade of the rebar. So how we are going to put the reinforcement with the spacing or with the number of reinforcement, we have the options here. Or if we have any the predefined settings, so what we are going to assign, that we can load and we can modify. And even we can share these settings with our colleagues so that we can speed up the process. And then once after the modeling of this portion, we can see with the clip planes, we can see the reinforcement arrangement inside the culvert. I'll be using one more the clip plane now. So we have 2 clip planes to check the reinforcement and their arrangements inside. Okay. Now once after that, we can check our drawings also. We check the model, and now we can check the drawings. And before that, let me just do the numbering. It is done. If I open the drawing, so basically I generated the cast unit drawing, which has all the information, including the concrete as well as the reinforcement information. And by default, we will be getting the bending schedule inside the drawing, and the different views also. So we have one of the view, that is the culvert top view, and then the reinforcement information also. And there is one more option where we can show all the reinforcement or only bars in the middle of the group. So I selected here the middle of the group so that I can see the reinforcement clearly. And then the different views. So we have different views which we can turn on, like the front view, top view, back view, bottom view, and then the 3D view. So here I took some of the views, including the 3D view. I have one section. This shows the bar mark number and the number of bars, the size of the bar and spacing between the rebars. It is very clear. And then the bending schedule, which we can see now, like it has the information like the bar mark number, diameter of the rebar, numbers in each, the shape code, length of the rebar, and even the shape of the rebar also. And weight for each rebar, and as well as the grand total also available in the bending schedule. And even we can add the 3D view, so that the site people can check the reinforcement arrangement and they can plan accordingly in the formwork area, the reinforcement part. And whenever we do some changes in the model, it automatically updates in all the deliverables, including the drawings. And even we can add some project information, and then the company logo, and rest all other details, including the revisions also we can add in this drawing. And this is a fully automated process. There's one more method to generate the reports that we are going to demonstrate now with the help of the object browser. Object browser is a dynamic reporting tool. So whatever the information we select in the model, so automatically this reflects in the object browser. So once after the selection, we can see the information like the bottom slab and the culvert top slab, the culvert wall, the haunch portion, and we can see the concrete volume also over here. The total is the 35.5 cubic meter, the concrete quantity of M30 grade. So this we can export in an Excel format, and in our own template that we can export. And now I'm going to export this concrete information. So similarly for the rebars also we can do. So this is just exported in an Excel format. And now we can see the report generated. So what I am going to do is I'm going to minimize this object browser and open the Excel sheet. And in the Excel sheet we can see clearly the logo, the company logo, and the grade of the material, and then the volume of the concrete quantity. So that is also there in the Excel sheet, so that later we can get the cumulative of the same, and then we can give it to the procurement department so that they can plan accordingly the procurement process. And then now we can turn on the reinforcements so that we can do some more the change management part. So right now the culvert length, the length of the culvert is 6,500 millimeters. Yes, it is 6,500 millimeters. And later date they asked us to change it to 8,000 millimeters. So there is some change in the model. So how fast we are going to handle those situations? So for that, what I'm going to do is I'm going to select the individual grid, and this grid I'm going to make it as a magnetic grid, so whatever the information I'm ordered here, like the reinforcement and the concrete part, even with the haunchers, so whatever the information connected with this grid, when I move this grid, automatically it follows the new concrete dimension. So this I'm going to move now to 1500 millimeters, and now it is updated, and now I can see the reinforcement also updated. And if I check the total the distance, now it is 8,000 millimeters. And if you can see here, the reinforcement what we modeled by using the custom component, and as well as the manual reinforcement, so both are updated, and it follows the new concrete the shape, and then parallelly all our deliverables also updated. So if I open my drawing, so we need to do the numbering in between. Basically, compared with the 2D workflow and the BIM workflow, it updates instantly in the all the deliverables. Now we can see the 2009 the kgs of the reinforcement is required, so it already updated in the drawing, and even with the new concrete the information, and it's already taken care in the drawing side. Now we are going to demonstrate how to model the substructure and the superstructure by using the Tekla structure library. And starting from the foundation, so we have a library for the different types of the pile cap and the piles arrangement, starting from the 2 pile to 9 piles. So I'm going to use the 9 pile now. So I have a pile cap modeled, and they're all parametric. The individual pile detail with the pile cap, the sizes, and even the pile height. So all the information is there, and we can control from one single dialog box. And now to model the reinforcement, I am going to use the component catalog. So where I have the reinforcement arrangement, and we can control the primary top and secondary top and bottom rebars in one single dialog box. And to model the mat foundation with the piles, I have a macro. So I have mat foundation with the piles. So this is the mat foundation with the piles. So I'll be deleting this reinforcement and even this arrangement also. So what I'll be doing is I'm going to remodel the rebars for this area, and they're all parametric. And this is the reinforcement, the dialog box. And now for the piles, so I have pile of 500 millimeter in dia. So what I'm going to do is I'm going to select all the piles, and in one single go we are going to modify to all the piles. And now I'm going to change this to 750 millimeters. So it's already updated now, and even the existing reinforcement will follow the new concrete the dimensions. And to model the reinforcement, we'll be using the one macro. This is a column rebar, and I have a rebar modeled. And now to change the rebar information according to my requirement, I'm going to load the one setting, and say here modified. And now to edit the height, again the same. We are going to select all the piles, and the levels we are going to modify now. Right now the depth of the length of the pile is 2700 millimeters. We are going to make it to 5000. So here apply and modify. So it updates, and even the reinforcement also follows the new concrete the boundaries. And then to model the pile cap. So I'm going to use the one macro, that is the raft foundation, and the reinforcement is modeled for the top and the bottom levels. And if I go to the plan view and in this area, and this is the pile cap with the reinforcement and the 4 piles. So later date, if I am going to modify this pile cap dimensions, that time also I can directly stress this, the pile cap, and the reinforcement is there already. And even you can go with the user defined the modifications. Now we can see the reinforcement is there and it follows the boundaries. And even if you have any openings, that also you can create, and the reinforcement understands the openings, so accordingly it does the reinforcement arrangements. And coming to the one more area, that is for the piers. So here we have the different types of the pier arrangements where we can model very quickly the simple, the semicircular one or the square one, or with the openings or the tapered portion. I'll demonstrate here those areas. So if I select this, there is a profile is defined. So I'm going to model the one column now. So if I model the column, so this is the column, and the position we need to check properly. The bottom level is 0, top level is 9000. Okay, and we are going to change this profile now. So whatever we copied, now we can see it is there already. So just working with the profiles. So basically very quickly we can model any user defined shape of the profile also possible. And if I want to modify to this shape, basically this shape what I modeled here for this the pier, I can change the profile to this one, and now we can see it is already updated. The profiles, we have different shape of the pier, the profiles readily available. By using that, we can model the piers as per our requirements. And even these kind of piles, and the next, the circular, the piers, and even the tapered portion here, where we modeled back in by using the profiles. And now to model this kind of the profiles and the deck, basically the deck, I'm going to use the beam. So I have beam modeled, and basically I have this profile. So I'm going to modify this to the new profile now what I selected, and now we can see it is updated. And at the same time, even its all properties like its quantities, everything is updated. Even if I inquire this part, and it gives me the details like what is the volume of this the part, basically the concrete volume that we can get. And even we can create the openings in the deck or in any selected the piers. We can create openings very easily. But there are different methods out there to create the openings. Now on the deck side, when we want to model the simple the deck, we will be using the slab the icon, and we model the slab here, and this we can assign as the deck slab, and the thickness is 250 millimeters. And to give the proper slope, so what we can do is we can use the handles, and by using the handles I can change the slope. So basically what I'm showing here is all are intelligent objects inside the Tekla structures environment. And here if I give it to 250 millimeters, now we can see the slope what we modeled in the deck. So very quickly, or we can go with the levels where we can give the 3 different depths for the deck, or even we can go with the curved part where we have the curved portion at the bottom, and even the T-beam deck slab bridges. So very quickly we can model that. So if I have the profile, so now to model, I'm going to use the beam, the icon. So I just selected the beam, and here it is with the dimensions like 600 by 800. I'm going to replace with the profile what I selected. So if I modify, I can see the T-beam, the deck slab bridge over here, and similarly for the other the shapes also. So different arrangement of the decks are readily available. that we can use. And if I want to modify that, I'm just going to use the same, and I'm just going to change the profile now. If I say here modify, now we can see there is change in the deck. Similarly, for the segmental constructions, so what we can do is we are going to use the profile, what I have already modeled, that is box C. So what I'm going to do is it remembers the old the profile. So I'm just using that, and I will be modifying with the new profile now to the box C. Now we can see it is updated. So basically creating a profile and modeling the deck is more faster and easier, and even we can control the proper slopes in it, and we can create some of the openings inside the decks. So some the openings in the sense to the locks, basically the locks that we can create, the interlocks that we can create here, that is also possible. And coming to the reinforcement side, so first I will start with the one already what I have with the mat foundation with the piles and the pier. I'll be showing the reinforcement part where the slope portion we can see the pier, there's a tapered portion, and we have the reinforcement modeled, the circular reinforcement, and even the vertical rebar, and even the drainage also modeled here. So, and these are all parametric. So anytime we can modify this rebar information. Just for an example, if I double click this rebar, so 32 millimeter diameter, and I have 45 number of rebars that I can change it to 25, so that we can see the reinforcement information updated over here. And this is basically the L shape of the rebar. So going inside the pile cap, and here we have this stirrup information also. And this stirrup information, let me just select this stirrup and show only selected. So we can see only the stirrups with the pier here. And these are all intelligent. We can change the sizes and the hook details, and even the spacings for that rebar, that is possible. And even we can copy and paste in the other concrete part also very fast. So if I redraw, I have all the rebar information in it. And similarly for the pile cap, again by using the macros where we can modify the rebar information. Right now I have 6 number of rebars, which I'm going to modify to 12, and now you can see the reinforcement is updated. And even when we change the depth, automatically it updates. And coming to the one more area, that is on the post tension part. So I have a simple post tension information modeled just to understand the feature. And this is the post tension macro where we have the size of the tendons and the spacing between the tendons, and the profile, how it is going to be. So we have different options available, and even the end blocks. So we have some macros to model these end blocks, and if required, according to the company specific end block details, that we can create and we can deliver the end block details. And coming to the I section, the girder here, where I have the varying section and even the different sections over here, we can check the post tension information modeled with the end block details. So here the tendon is 3D profiling. That means it varies in X and Y and Z coordinates. So accordingly the tendon is modeled, and even the regular reinforcement, what we see in the such I section girders. So we have the reinforcement information modeled, and these are all manual reinforcement where we selected the range and the reinforcement is there already. And similarly for this area where we have the reinforcement, let me just select the reinforcement here, and if I say here show only selected, now we can see the reinforcement very clearly. So modeled in the I section, and They're all parametric. Anytime we can update that reinforcement, the spacing. And if I redraw, we go back to all the reinforcement. Here they have a situation where this reinforcement is obstructing or clashing with the post-tension end block. So what we can do is we can delete that reinforcement or we can adjust with the spacing. So both way it is possible. So what I'm going to do is I'm going to ungroup this rebar and I can select this rebar and I can delete. So basically check the clashes and accordingly we can adjust the reinforcement with the proper cover. That is possible. Now we are going to demonstrate on the curved alignment where we have the profile and that profile need to follow the curved alignment. So for that I am going to start with one of the plugin, that is the extruder what I have, and this will allow me to model the profile in the curved portion. And here I am going to select the XYZ coordinate what I already modeled. So if I select one of the Excel sheet where I have the XYZ coordinates, and by using that I'll be able to model the curved profile very quickly. And now I have the profile. So we can see the profile in the curved portion. So if I show you in the plan view, now you can see it is in the curved portion. And individual segment, if I select this individual segment where this side length is 2504 and if I measure on the other side, okay, now it is 2300. That means it takes care of the arrangement of the concrete portion in the curved part. So now to come back to the reinforcement side. So very quickly how we are going to model the reinforcement in the curved portion. So here we have some the plugins. By using that very quickly we can model the reinforcement for that. So let me select one of the view. So by using that I'll be modeling the reinforcement where we can model the reinforcement like the main bar, even the stirrups. So for that I'll be using the plugins. So here I have one of the crossbar. So I'm selecting the points, basically defining the shape of the rebar in this portion and selecting the points properly, and then these are all points selected, and then it will ask me to select the beams where we want to put the reinforcement. The beams are already selected now, and now this will put the reinforcement, and now we have the reinforcement all around in the curved portion. So we can see the reinforcement now in this area. And for these hooks we have the options where we can change the hook position and their orientation. So what I'm going to do is I'm going to use one of the custom defined the hooks. So if I mention here the 90 degrees on the other side, now the reinforcement is there, and the length also we can control. So let me say here 75 millimeter on both the side, 75 millimeter, modify with or without the hook also we can model this reinforcement, and this allows me to model the reinforcement with the 90 degree hook or 135 degree hook or with the custom defined hook also. Now the reinforcement is proper. Now we are going to use one more the area, and even we can hide this reinforcement also. We can give the number of reinforcement or even with the spacing also possible. I'm going to hide this reinforcement so that I can add the other the main reinforcement for that. So I'll be using this main reinforcement, and just showing the range. And then selecting the beams, and this will model for me the reinforcement, and now I can see the reinforcement modeled throughout. And here we have the options where I can change the grade of the reinforcement and the size of the reinforcement, and even we can do the splices also. So let me select FE415, the 25 mm the main bar. I say here apply and modify. And here we have the options where we can go with the splices. I say here yes, and we can give the stock length of the rebar and even the splice the splice length. So that will model for me the reinforcement. So accordingly we can model in all other areas also. With the splices, and now we can see the splices added for the reinforcement. Different types of splices options are available, where one can go with the splice only on the left side or on the right side or even on the both the sides, and even we can go with 1 in 6 or 1 in 10 the rebar cracks also. So we can see the rebar laps here, and now on the stirrup side. So if I add the stirrups, selecting the member, the 2 points on the range, and we need to select the beams here. Now we can see the stirrups also modeled, so with the proper spacing, and now we can redraw so that we get all the reinforcement what we modeled earlier. So now we have the main reinforcement in the cross section, where we can see the main reinforcement and as well as the stirrups and even the longitudinal rebar with the proper splices. So in the curved portion also one can model the reinforcement very quickly, and once after that, so I have the PS modeled already. So what we can do is very quickly we can move that part also possible. So I selected the deck portion, and we'll be moving that by selecting the position. Okay, it's selected. We can keep this properly on the bearing pad. Now we can see the reinforcement, the deck portion modeled in the curved part with the proper slopes, and one can adjust by moving the deck. So let me just redraw. So now we can see the whole portion over here with all the foundations and the pier information and the curved portion. So basically these profiles what I used, that can be modeled very quickly. That is a user defined the profile. So if I go to the custom component catalog, so what we call, there is a library, and here we have some sketch profiles, and if I select this one of the profile, so what I used just now, it is with the proper slope, and this is a user defined one, so user can change, and this he can create as a parametric one even with some openings, that is possible. So basically in working in the curved portion is more faster and easier in Tekla structures. There were a few questions on the viaduct, so I thought to demonstrate that part also. So I have one viaduct where I have the reinforcement modeled in most of the areas. So let me just zoom into one of the area where I can show the reinforcement. So I have the reinforcement for the pile cap and the piles, and even the reinforcement which is inside the pile cap, as well as in the pier head also. And I have the reinforcement for the pier head and the bearing pad also modeled. So very quickly what I'll be doing is I'll be taking this I section girder with all the reinforcement in it with the post tensioning tendons modeled. So I'll just copy to to this respective location. So let me just select the I section girder, and I'll be copy from this point to these areas. Just placing into the certain locations. And it's already copied. And I'm just selecting the points, the pick points. And here I have some more the points where I need to copy the pier, the I section girder, And there's one more point which I missed in the beginning. Okay, now all the I section girder has been copied to their locations. Now we can go to the plan view and remove the what I used in the beginning, and we can work with only one section, and later we can just copy to other areas. It's more faster, and I need to copy the deck portion also. So I'll just copy, and I'll use some pick points from this point to this point. So it's already copied now. Now we can see the half portion completely modeled with the text prepared. Now we can do the numbering, so that for each and every cast unit we can get the proper labels, and even for the reinforcement we get the bar mark number. So it's already done. So now we are going to open one of the drawing. We can generate the general element drawings, where we are showing the longitudinal view of the whole viaduct, and it will generate the drawing in a moment. Okay, it is generated already, and I can see the details, like where here I place the deck, and here are the I section girder, the modeled, and showing the direction, and longitudinal elevation, the left carriageway. So I need some the sections, so that what I can do is I can directly go to the view, because the drawing is intelligent, where I can select any of the points and I can generate the sections very quickly. So I took one section. So once we generate the drawing, we can generate the sections very quickly, and this is one of the view. So let me just change the view depth in all sides, and it updates with the view depth, and we can place it properly, and so I have even the cross section, where it is showing for both the left carriageway and the right carriageway, and we can label with their respective the part names. And I need one more section, so what I can do is I can generate one more, the section view, and then we can place one of the location, and again the same for each and every section. We can control with the scale, and if required we can add the reinforcement details also, and I can select here the reinforcement marks. So I'll be showing the fill line, so I can make it visible here, not for all the rebars, only the bars in the middle of the group. So now we can see the reinforcement in the section also. So like this, very quickly we can generate the drawing, and out of one longitudinal section we can generate any number of the respective cross sections, and we can put the part labels and the reinforcement bar mark details very quickly in the GA drawing. And even we can add some of the notes also here, the general notes, what we normally add in the drawing, that we can do. And these drawings directly we can print from Tekla structures environment, and if required we can print as a PDF, or we can export in a DWG or DXF format also possible, so that we can share the drawing information with our colleagues who are working on the any other CAD platform. That is also possible. At last, I would like to share one of the customer project where they use Tekla structures, and the reinforcement information as well as the whole structure has been modeled, and with all the post-tensioning information in it. And we can zoom into that the post-tensioning area, even the reinforcement, and any user defined the shape of the pier that one can model very easily with along with the reinforcement. And even I have the small video to play over here that the customer project details, where it is showing the whole section, the pier and the segments and the normal reinforcements, along with the post tensioning tendon, basically the seating portion. And we can see in the small clip the reinforcement arrangement, so where we can walk through and check all the reinforcement arrangement very clearly. So basically the junctions are the weaker portion, so one need to check very clearly the reinforcement information, so that the site people can work accordingly and they can do the proper concreting. So this is one of our customer project where they use Tekla structures to model this bridge structure. So now we are going to the summary. Now to summarize the whole session, Tekla structure is a cost-effective and versatile beam solution in the area of reinforced concrete for the bridges, and we can create the whole 3D model, the bridge model with the rebar information and post tensioning information, and even the embeds very quickly and accurately, and we can generate all the deliverables including the drawings and reports and bar bending schedules. And to automate the process, even we can link with the machineries also. So where the bar bending information goes to the machine, and according to the shape code, it cuts and bends the rebar as per the reinforcement arrangement what we did in the bridge model. And even we can communicate with the site people by using the free tool from Tekla, that is Tekla Beam Site, during the construction. So, and then
okay, now it's time for the question and answers.
Hi Shekhar, this is Mishti. We have few questions which have come through mail. I'll start with the first question. Does Tekla covers new detailing provision of IRC 112?
Okay, it's a very good question. As per the Indian Road Congress, like 112 in the 2011, there are few, the details what they added for the reinforcing steel as well as for the pre-stressing steel. When it comes to the reinforcing steel, like the bend diameter, bond length, or the lap length, even the anchorage length, or the splicing and the bundling part, so they mentioned it very clearly. And on the pre-stressing side, it is more on the cable ducts, cover, the coupler, the post tensioning system. Yes, it is already there, and at the same time Tekla will allow you to the customize and change the details. Even we can do it the manual also we can adjust, that is possible. And at the same time in the IRC what they added is the 7 new grades starting from FE 2502 up to 600 including the D. So there were actually the 3 chapters what they added. It's a very good the amendment in the IRC 112. Yes, Tekla it supports. Yes, Misty.
Next question is, can we do both steel and concrete bridges?
Yes. Today we discuss more on the concrete side, but Tekla supports steel as well as the concrete part, where one can model all types of the bridges, starting from what I can say, the plate girders, box girders, so even the cable stayed and suspension for all types of bridges, even for the road bridges or the the road bridges. So it supports, and in one single model we can put concrete as well as the steel together. It is possible. Yes.
Third question is, I have 2 kilometers chainage with few culverts and minor bridges / structures. Can this be modeled? Sorry.
Okay. Tekla, we can do the modeling, like as you said, how the 2 kilometer chainage, where different structures are there, like as you said, like the culverts or the minor bridges or the cattlewalk cum drainage or some other structure. It is possible. It is possible where we can model the 3 structures in one single model. Yes, it is possible. Even the steel and concrete. Yes.
Okay. Fourth question is, I am a contractor. For billing, can I generate the quantities as per the execution?
Yes, in fact, even in my demonstration I have shown, like the quantities can be generated, like the concrete quantity or the reinforcement quantity. We can, generate where we can select the member or select the portion or the whole structure in one single go. We can generate the quantities. Yes, it is possible, and very quickly we can generate, all the quantities. It can be in an Excel format or HTML or some other formats. Yes, it is possible. We can generate the quantities. For for the you can do
Okay.
that and for the building. Yes.
Okay. The fifth question is, do Tekla provide training on software?
Yes, with every new implementation, we provide the training, what and all we have shown so far. So the 10 days of training will be there, where we come to your office and we do the training, okay, including the basic and the custom components and custom component training. The 10 days of training will be provided with the support and services. Yes, it is there.
Okay. There are a few questions. Can you just check the question box, because I cannot see that.
Okay, there is one question, where they're asking on the analysis and design. Okay, so normally, the companies, they use the application like the StatPro or the Midas or SAP, some tools they use, where they model, only the beam portion, I mean the deck portion, and they apply the loading manually. But at the same time, we have the interoperability links, where we can link with the third-party application like the STAT or the Midas. We can link with that and we can bring the information. Yes, that is possible. Is there any other questions, Misty? Okay.
There are few, but I'm not able to.
Okay, due to the time constraints, you're not able to, accommodate. Okay, so we can answer them, individually. And at the same time, I would like to inform all, our next webinar is going to be on the 1st of April, where we are discussing, where, the rebar fabricator from Midland, the steel, how we utilize, the Tekla, win more work. So he's going to discuss on that. Please register and attend that webinar. Thank you very much. If you have any questions, you can email us, and even you can call also. Thank you very much. Thanks for your time.
Thank you, everybody.